Okay, everybody, this is Compufire again from the GS Resources, and I'm going to do a quick overview of the connections and the mounting of the SolidStatePowerBox. There's a first video introducing the SolidStatePowerBox and how it is I interconnected to this test station and go through the functionality and stress testing of the power box. So now we're going to talk about how you really would connect this. I'm using as an example here the side plate, the electronic side plate that's normally mounted in rubber from my 1983 GS 1100E. The power box will mount right here, and that will be instead of this stock fuse box. So you can see that the form factor is pretty close. I mean, the SolidStatePowerBox is a little wider, but the mounting locations for the holes are going to be identical. I'm also going to show the interconnection, because that's the other benefit that you're going to get with the SolidStatePowerBox is we're basically going to eliminate the interconnections between the RR, the battery, and the harness, and really pull this to the side plate and really isolate it from the harness. So the SolidStatePowerBox, when you get one, if you choose to order one, will have 3 wires that we've talked about in the past. The first red primary wire is the connection to the battery, and I will be connecting this wire to the back post on the starter solenoid, which has a thick 8-gauge wire coming in through this back hole in the side plate. It'll have a 15-amp fuse. This could be made higher depending on what accessories you may have. I don't really have any significant accessories on my 1100, so I'm just going to stay with a 15 amp fuse. The other red wire, so everybody knows that you hook to the battery and you hook to the RR, and in this case I didn't use a connector. I went directly into the Compufire 3-phase regulator I have. The Compufire uses 12-gauge, a large insulation on a 12-gauge wire. The SolidStatePowerBox uses a 14-gauge. It's adequate for the types of currents we're talking about. If you get if we were to climb above 25 amps, then I might consider something different. But for the at 20 and below, we're perfectly happy and not going to be stressing anything by using a 14-gauge wire. The third wire is a ground wire, and as I mentioned earlier, this is not a ground return for any of the power that's coming through these wires from the battery or going to the harness. It really is the power that it's a return for the power that the box uses to control the motorcycle's power. So that really is in a standby case is 2 milliamps. Or if you're flashing lights, it takes 20 or 30 milliamps depending on if the light's flashing or not. So that's what this ground is for. It also provides a shunt path in the event that you have a conducted emissions and pulsed current spikes. This is also necessary, so that's why it's a pretty decent gauge wire. I think it's only a 16, but it's still it's necessary for that, and that's why I want to make sure that we have that ground rather than using the base plate, because that was a consideration during the design. But I don't want to have to worry about that. I want that, make sure that goes to the single point ground. The other connections you'll see here are, since we're talking about grounds, is a little mini harness for a single point to implement the single point ground in an easy, straightforward way. What you'll get when you get your SolidStatePowerBox is this little harness. It'll have a 3 ring lugs on it, possibly 4, depending on if you tell me you got a Compufire. But the large steel-colored ring lug here, if you can see that in the video, connects a 14-gauge wire, which is the primary wire return ground for the RR, and you'll see that's this wire here. The other 2 are grounds for battery and frame. The in this case here, I've already connected it to the that little mini harness to the RR. Again, I'm not using a connection or a connector. That a lot of these, I think they originally came with this weather pack type connector. I left it on the stator because there are times you want to disconnect the stator, but these primary connections are very sensitive to small voltage drops and small amounts of resistance which will affect your charging. So in the case of this Compufire, where the case of the Compufire is literally the ground return for the device, the grounds are attached by tapping in, a tap screw into the housing, and so I just put a ring lug on the end of this. That's where I mentioned I'd had 3 ring lugs, so that actually is 4 in total for this little mini harness to implement the single point ground. On the plate here, we'll have the Compufire mounted up here in the corner. The plate has been modified. I welded on 2 additional screws, one on the back, one on the front, to mimic the way that the original 2 holes were. But you can see there's a width difference. I actually, things are pretty tight on this plate, which is one of the big drivers for doing the SolidStatePowerBox, to make sure that I stay within the space confines of the original fuse box, and we've come very close to that. But I inadvertently had welded this nut over, and there was quite a bit of weld that was actually interfering with the heat sink that was on the fuse box, the SolidStatePowerBox. So I've, in the meantime, ground that off and painted it a little bit. So when we bolt this down, we're going to get actually a good conduction path for the whatever heat, say 5 watts or maybe 7 watts if you really increase the loads that you're going to put on the SolidStatePowerBox. Whatever heat is being generated is going to go into the heat sink, and the heat sink will then conduct to this plate. So it actually gives you a very large area and plenty of conductive surface area to dissipate heat away for just the 5 watts. So this thing should run quite cool. I don't expect it to be more than about 20 or 30 degrees above ambient. So if it's even if it's 100 degrees outside, if the device in here is running at 120 or 130, it's well within the specs for it, and given some good heat conduction, it may be quite a bit less than that, but I don't know yet because I haven't been able to measure it. I haven't actually installed this with a SolidStatePowerBox that has the conductive potting material, the heat conductive material. So we see here on the end, I've also got the basically a Suzuki OEM starter solenoid, but I have modified it. I've added an additional wire, which is the start signal wire. This comes from the kill switch. When you depress the start button, 12 volts ends up being applied to this wire, which causes the solenoid to ground through its plate. And that's why sometimes when people are messing with their bikes and then they find their bike won't start, they forget that this plate has to be grounded, both for the RR, but also the solenoid has to be grounded for a ground return. So anyhow, getting back to the wire, this additional wire will be added to the pigtails that come into the connector, the 10-pin Molex that comes into the bottom of the SolidStatePowerBox. So it'll be mounted here, and it'll be coming in the bottom like that. So those are the pieces that are going to basically, it's going to look something like that. And in the next video, I will put this together, including all the wires and the ring lugs. There's going to be 3 ring lugs that come to this point right here as a single point ground. So we'll see just a minute, and I'll install all these items.